Let's say this is your street where you live, and let's say this is your house where you live. We're going to say that this is, whoops. And if you don't live in a house, then just pretend you do. Okay, your house where you live, and this is your street, okay? So this house right here that's right next to your house, right? We often call that the house next door, okay? That's the next door house, okay? And then if you were to walk out of your house, right, and you were to stand right here and look across the street, you would see this house, right? And so this house is often called the house across the street, okay? The house across the street, okay? The house across the street is the house that is straight across from your house when you walk out your front door. The house next door is the house whose yard is touching your yard, right? So this is your yard, this is their yard. And look, their yard is touching your yard, okay? All right, great. Well, these concepts are important in understanding triangles, okay? I'm going to give you new words that represent your house and the house next door and the house across the street, okay? If this is your house, we would call the house next door, we would call that house the adjacent house, the house that is adjacent to your house. Adjacent means next to slash touching, okay? So it's the very next one. That's what adjacent means. It's the very next one. It's next to whatever the thing is. And then when we say that something is across from, we say that it is opposite, okay? When something is opposite, it is across from, okay? So like, let's say that you were sitting at a table at a restaurant. All right, here's two people who are sitting at a table together. Let's say they're sitting at a restaurant, okay? They are across from each other, therefore they are sitting opposite, okay? So this person right here is opposite this person right here. They are across from this person. This chair over here is adjacent. There's nobody sitting there, but this chair is adjacent to this person. So if this is you, let's say that this is you sitting at a restaurant, and this person is opposite, and this chair is adjacent, okay? Adjacent means next to and touching, okay? The very next one, okay? Let's look at another example of people sitting at a restaurant. All right, look at these four people, these four young people. They look like they're having a good time at some kind of diner or restaurant, right? Okay. Well, these two people, how are they sitting? Are they sitting adjacent or are they sitting opposite? Okay. Well, they're next to each other and touching, so these two people are adjacent to each other, okay? Also, these two people are adjacent, and these two people are adjacent. But this person and this person are across from each other. So this person, and this person, they are opposite each other, okay? All right, now the reason I'm trying to review these two words, adjacent and opposite, is because we are going to use that concept in referring to the legs of a right triangle as compared to the angle of a right triangle. All right, so what we're going to talk about are the sides of a right triangle relative, here's the key, relative to the acute angles. Now we know that any right triangle has two legs and a hypotenuse, right? So two legs and a hypotenuse, okay? Now, the hypotenuse is always the hypotenuse, but the legs can actually be referred to in different ways depending on the angle that you're looking at, okay? So I want to introduce you to a couple of Greek letters. The first one is called beta. This is the Greek letter beta. It's a lowercase beta, okay? This is the Greek letter theta, Okay, now you may have heard some of these words like when they talk about like sororities and fraternities in colleges, like sigma, beta, or mu, alpha, theta. That's actually a high school math fraternity, but anyway, these are Greek letters, beta and theta. Okay, now these Greek letters are often used to represent, they're used as variables in representing angle measures in a right triangle. So if we have a right triangle, what we'll do is we'll go to one of the acute angles. Okay, we never call the right angle anything. The right angle is always just the right angle. It doesn't get a lot of attention. It's just sort of there making the triangle a right triangle. What we really care about is this acute angle and this acute angle. And so sometimes we'll put the letter theta in here, theta, and we'll put the letter beta in here, and we'll say that this angle is angle beta, and we'll say that this angle is angle theta. And more specifically is we'll say that theta is representing the angle measure. So for example, theta might be equal to 63 degrees, and beta, if theta is 63 degrees, then beta is equal to 27 degrees, because 27 degrees plus 63 degrees equals 90 degrees. Okay, so really all I'm introducing to you is the idea that we often use the Greek letters beta and theta to represent the angle measures of the acute angles in a right triangle. So let's say that we have this right triangle, and we're going to put a theta in this angle. We're going to call this angle angle theta. Okay, well, based on angle theta, so this is going back to the thing about the house, right? And the next door, and then the house that's adjacent and the house that is opposite. Okay, what we can do is we can talk about the three sides of a triangle. This is a hypotenuse, this is a leg, and this is also a leg. The hypotenuse will always be called the hypotenuse. It will never be called anything other than the hypotenuse. Okay, so we're just going to call that hypotenuse. But the legs can't, we can call them leg 1 and leg 2. Sometimes we call them A and B. But we really want to start talking about the legs in terms of their orientation to one of the angles. So this leg compared to theta, and this leg of the right triangle compared to theta. And here's what I want to show you. Do you see how theta is made up of the hypotenuse and this leg? These two, the hypotenuse and this leg, make up the angle theta, right? And so this leg that actually makes up angle theta is touching angle theta. And because this leg is touching angle theta, we call this leg the adjacent leg, or the adjacent side. So this is the adjacent side. It is adjacent to theta. Okay? And then this leg over here, or this side of the triangle, is not touching theta. It's all the way over there, and it's across from theta. If you draw an arrow straight out from theta inside the triangle, it will point at that leg. And because this leg is across from theta, we call this leg opposite. This is opposite. This leg is opposite to theta. So this leg is adjacent to theta, and this leg is opposite to theta. Okay, so what if we have a right triangle like this one? And what if, instead of putting theta down here, what if I put theta up here in this angle? What if I called this angle theta? Well, then what is this side called? Well, that's the hypotenuse. Remember, I told you that the hypotenuse is always called the hypotenuse. Okay? Well, what would we call this leg right here? Well, this leg is a part of theta. Theta is made up of this leg and the hypotenuse, right? And so theta is touching this leg. So even though in the last time we called this the opposite leg, now we're going to call it the adjacent leg. This one is adjacent to theta. Why did we change it? Why was this adjacent before and now this one is adjacent? Because we moved theta. We moved theta from here to here. And what's important to understand is that the leg that we call adjacent has to do with where theta is. It is relative to the angle. So whichever angle you're talking about, the one that's touching that angle is the adjacent. But what's across from theta? Across from theta is this leg. So now this leg is the opposite, to theta. Okay? And so now what I'm going to do is I'm going to name one of the angles theta, and I'm going to name the other angle beta, and we're going to identify which leg is adjacent and which one is opposite to both theta and beta. Okay, so let's say that this angle down here is angle theta, and this angle up here is angle beta, okay? Well, what are we going to call this side of the triangle? Well, that's the hypotenuse. We always call the hypotenuse, okay? And also, I want you to know I'm going to stop writing the word adjacent. I'm going to use ADJ. This is going to mean adjacent, and I'm going to use OPP to mean opposite, okay? So this means adjacent, and this means opposite. And HYP, that means hypotenuse. Okay, so what we want to do is we want to label this leg right here, okay? Well, this leg is, look, it's touching theta. It's right next to theta. Theta is touching this leg, and therefore this leg is adjacent to theta. Okay? But this leg is also across from beta. So beta is not touching this leg, and therefore this leg is opposite to beta. So it really depends on which angle you're talking about. If you're talking about angle theta, this is the adjacent side. If you're talking about beta, this is the opposite side. All right, now what about this leg right here? What about this side of the triangle? Well, this side is touching beta, and therefore this side is adjacent to beta. ADJ adjacent to beta, okay? But this side is not touching theta at all. It's across from theta, and therefore this side is opposite to theta, okay? And so when we talk about the adjacent side and the opposite side, we have to be referencing one of the angles of the right triangle. We can't just say, oh, here's a right triangle and this is the adjacent side. No, this side is only adjacent to this angle. This side is opposite to this angle, and so it depends on which angle we're talking about. Because it's the same thing as on your street. If this is your street and this is your house right here, if this is your house, this house across the street is opposite your house, right? But if we were saying, well, instead, let's talk about this house right here. This house is adjacent to this house. So this house is opposite your house, but this house is adjacent to this house. So it really depends on the house of reference. And in these right triangles, it depends on the angle of reference that you're talking about, okay? And so all I wanted to do is introduce in this video, I wanted to introduce you to the idea of sides of a triangle that are opposite to an angle or adjacent to an angle.